Alright guys, one more video. Again, trying to include the inverse in some of these double angle, half angle, power reducing, or sum difference formulas. So here we go. We have another inverse problem here. Notice here the inverse tangent of -4/3. Well, inverse tangent, remember, this is just side lengths, 4 and 3. So we're going to draw this out. Now notice where I draw this triangle. We're going to be drawing it in the fourth quadrant. And why we're drawing it in the fourth quadrant is if the inverse tangent is negative, right? Inverse tangent, we can always only draw reference triangles in the first and fourth quadrant. If it's negative, it has to be drawn in this fourth quadrant, indicating that this side length is -4, that side length is 3. I'm going to go ahead and label this angle as just theta. Now, similar to our previous example, the inverse tangent, right, or inverse cosine or inverse sine, all that does, it spits out an angle back to us. Now, do I need to know the value of this exact angle? Not really. All I need to know is that this theta refers back to this tangent, or that this inverse tangent gives us this reference triangle. So I can go ahead and rewrite this problem as cosine of 2 theta. And theta is the answer to this portion of the problem. This is equal to theta. Well, cosine of 2 theta, this is a double angle formula. Cosine of 2 theta has several different ways of writing. Now, a couple of you guys sent some message to me yesterday about which double angle formula to use for cosine. Doesn't really matter, right? It really doesn't. Now, sometimes some examples are more efficient than others. In this case, it absolutely does not matter which one we use. I'm going to expand cosine 2 theta to be cosine squared theta minus sine squared theta. And doesn't matter which one I use. But, well, theta, it refers back to this reference triangle. Now, we might go ahead and use Pythagorean theorem to indicate that this hypotenuse is 5, because I'm going to need to know that information, sooner rather than later. But now I can go ahead and answer this problem. Well, cosine of theta squared, well, cosine adjacent over hypotenuse. 3/5 squared. And sine squared, -4/5 squared. Now, simplifying this problem, we would get 9/25 minus 16/25, which would come out to be -7/25 for our final answer. Now, just to recap, I want to do a quick recap of this problem one more time. Anytime we get an inverse problem, it is just to help us come up with this theta value. We don't need to know what that angle is. I don't care what that angle is. This just helps me draw that reference triangle. Once I have that reference triangle, then I can go ahead and use my double angle expansion or power reducing or sum and difference formula like my previous problem. Okay? On Math Excel today, you guys have a couple of problems involving inverses to kind of mix in with these different ways of expanding sine, cosine, and tangent. All right? Same as always, reach out to me if you guys have any questions. You can comment on Google Classroom or send me direct emails. And yeah, have a good weekend, guys. Thank you for being patient, bearing with this new reality we have to deal with. All right, take care, guys.